Hello everybody. In this video, we will discuss about ECU identification and configuration. So to proceed further, in vehicle diagnostics and onboard diagnostics, reading ECU identification configuration is a crucial step in understanding what electronic control units are present in a vehicle, what software and hardware they are running, how they are configured. So this information is very important and this information must be clearly extracted. This information is necessary for matching vehicle-specific diagnostic procedures, validating correct ECU software versions, performing ECU performing ECU programming or replacement, ensuring compatibility with diagnostic tools and tests. Okay, so these are the reasons why this information is extremely important. Now, what is meant by ECU identification? When you say identification, what does it exactly comprise of? ECU identification refers to process of retrieving standardized and manufacturer specific information from an ECU. Okay, so this may include ECU part number, software version, hardware number, vehicle identification number, system supplier ID, programming date, serial number. So, and of course, right side you can see the corresponding values. So this whole information is what is included when you say ECU identification. And what are the protocols used for ECU identification? ECU identification is done via diagnostic protocols such as UDS, KWP 2000, ISO 15765. Okay. Now in UDS, the service used is service 0 by 2020 by 22 read data by identifier. So this is the service. For example, request 22 F190 request for win. This is the response. Okay, when you say 22 F190, which is the request, you will get the response as vehicle identification number. Now, what is ECU configuration? ECU configuration refers to retrieving or modifying internal settings or coding values within ECU. It defines vehicle options, localization settings, feature flags, coding values. All right. For example, vehicle option means whether it is cruise control enabled or disabled. Localization setting means region, language, emission standard. For example, whether it is from India or America or Europe or Japan, that is clearly identified. And when you say feature flags, whether it is ABS active, anti-locking braking system active, what are the parking sensors, and the coding values, long or short binary hex codes representing specific setup. Now, how to read ECU identification and configuration step by step. What is the procedure? So, what comprises of ECU identification is fine, but what are the further steps that need to be taken to methodically identify an ECU, to identify a ECU? So, first you connect the diagnostic tool, use a diagnostic scan tool, OEM tool like TechStream or VCDS or ISTA or aftermarket market like Launch Autel. Connect to the vehicle OBD port via OBD port. Establish communication, initiate diagnostic communication with specific ECU, engine ECU, ABS airbag, and enter an appropriate diagnostic session, whether default, programming, extended using UDS service. Next is you read, this is where exactly you read the ECU identification. All right. So for each and every UDS request, 0 by 22 F187 for hardware number, another UDS request for software version, another UDS request for win version, and the ECU response with the corresponding value interpreted by tool. Now read ECU configuration if supported. Okay, so these also services like 0 by 22, 0 by 31 for reading the configuration, for reading their configuration IDs, routine control. Some configuration need to run via routines. Some ECU support coding data read out via proprietary commands or tools, and view or log data. The diagnostic tool displays ECU identification and configuration data can often export to CSV or PDF for safer offline reference. So once you see the data, you can always export it to Excel or PDF depending upon your convenience. Now, whenever you are extracting data, there is a primary concern called security consideration. Access to configuration or extended identification data often requires security access. UDS service 0 by 27 may be needed. Challenge response mechanism involving a key seed change. Unauthorized modification may lead to ECU malfunction, loss of warranty, regulatory compliance. This is very important because some unauthorized modification may lead to your OEM say that warranty is not valid. Okay, for example, UDS over CAN. All right, so these are the various requests and these are the meanings. Okay, over CAN means over the CAN protocol. How exactly are you requesting over the CAN protocol? Okay, so some use cases is when do you exactly need to identify or configure the ECU? Before ECU programming or cloning, during retrofitting features, validating software after firmware update, and matching part numbers for replacement ECUs. Okay, so these are all the various use cases. And when it comes to tool examples, tool like VCDS for Volkswagen Audi, detailed coding and adoption, ISTA for BMW Mini, TechStream for Toyota Lexus, Diagbox for Peugeot and Citroen. On the right side, you can clearly see what exact feature is identified in ECU configuration and identification. Okay, thank you.